What is a dimension actually? A dimension is a linearly independent degree of freedom. Thus, we define dimensions in terms of linear algebra. We can define a function's dimensionality as the number of basis vectors we need to represent that function. So a trajectory in three-dimensional space where we can move in three different directions requires three basis vectors, x, y, and z if we're in a Cartesian coordinate system. In some cases, we may only need one or two basis vectors. But what about infinite dimensional spaces? In quantum mechanics, we treat dimensionality not just in terms of a spatial trajectory of an object, but of the solution set of functions themselves. And functions can be infinite dimensional. So for example, when we solve the Schrodinger equation in some cases, we need an infinite number of solutions, and each one of those solutions represents a separate dimension. But it's not a dimension in a spatial sense like we can move in infinite dimensions. It's more like this abstract linear algebra sense. So when you hear about quantum mechanics and infinite dimensions, it doesn't mean that we have infinite dimensions actually. Everything could be taking place in 3 or 4D space-time if we're talking about relativistic quantum mechanics.